Hello, how are we doing? Okay. Welcome to the tutorial on how to do task 2 in Sheets. What I'm going to try and do is take you through the technical aspects. We're not really going to touch on the mathematical aspects that you're still going to need to do in your Lonesome. Okay. But I want you to be able to see how to do the project in Sheets. Okay. So let's get started. What you're going to end up with is something that looks like this. Okay, so you're going to have a normal curve on top of a set of data represented by a histogram. Okay, and you can see where the curve matches the histogram, where it doesn't, and you'll be able to use the normal techniques of a probability distribution and the data and come up with some questions. Okay, so what's the probability by the normal distribution that a day would be hotter than this? What's the probability of that the day is actually hotter than this? Where do they match and why are questions that you can ask. Okay, and you can go as deep and as thorough as you want, or you can do a very solid job on questions from the textbook that have very single answers to them, and do a solid job well, or go as far into the depth as you want. Okay, but let's get started with the technical aspects. Okay, first thing I did is I went to, I went to the Bureau of Meteorology, found climate data online. I went to Weather and Climate. I went find. I'm going to do a different place because I just did something and I wouldn't mind looking at something different. Let's go to Palmerston. And we'll go Palmerston in the NT. And then we'll go on something where there's no weird climate events, and they're going to have go Kangaroo Flats. Okay, get data. That is not what I wanted. Let's go again. Palmerston, Kangaroo Flats. Oh, daily weather. I don't want weather and climate. I want daily temperature. Sorry about that. Temperature is going to fit a lot easier into normal distributions. But I still want Palmerston NT. And actually, we might go Darwin Airport this time. Why not? And then I'll pick it. Last year I was in Darwin, which was 2015. Okay, and we should be good to go. Hopefully, fingers crossed. Yay. Okay, going to select all that data. Notice that there's a day where the good people of Darwin weather station didn't get an accurate recording. Could be a cyclone, could be unusual weather event. I don't know. Okay. Then I'm going to open up a new sheet. Okay, I'm going to put that data into the new sheet. I'm going to bin the first column because I don't want that column. Then I'm going to highlight all of it. I'm going to give it a name. So I go to Insert. Sorry, I don't go to Insert. I go to Data, Name Ranges. I'm going to call it Palm for Palmerston. And that just names all of the data I've highlighted. So instead of finding ranges and stuff, I can just type Palm for everything. So I want the Palm minimum. I want the maximum. So I can find the top and bottom value and look in between them. I want the average. And I want the SD. So the minimum equals, min, open brackets, PALM, close brackets. Palmerston's minimum was 26.9. Its maximum equals MAX, open brackets, PALM, close brackets, maximum equal, Control Z, get rid of that. Undo. So now I want the average equals average, open bracket, PALM, close bracket. I misspelled average, I feel very sorry. Equals SD equals ST standard deviation population. Yay, click the white one by mistake. Palm again. Every time I want that range, I want Palmerston. Okay, so it's got an average of 32.6, a standard deviation of 1.66. Okay, and the minimum value is 26, the maximum value is 36. So I'm going to go from 25 or 26 to 26 plus 1. All I'm doing is I'm just getting the counting numbers from 26 to 27. Sorry, 26 to 36. So I might go 37. Okay. Now, this is my buckets. And so I'm going to give them a label, add range, bucket. Like this before. Delete bucket. Okay, so what the computer's going to do is instead of me going 26, 29, 29, and putting a 1 in 26, another 1 in 26, and then 1 in 29, I'm going to get the computer to do the count for me. Okay, so the way I do that is I go equals frequency, open bracket, range first, which is palm. Then I want the buckets, which is bucket. Close brackets, enter. So 2 to 7, 15, then it gets really big, then it gets really small again. And that's what we'd expect for 300s. Okay, now this is the next bit. Oh, sorry, I'll go back to that sentence. That's what I'd expect for 300 numbers. About a third of them in the middle, and then branching out with some 5 below, some 5 above, with that sort of standard deviation of 1. Okay, now, what I'm going to do is also generate a normal curve. So what I want is equals norm dist, open brackets, and I want to pick an x value that it'll place in a normal distribution. It also needs an average and the standard deviation. And it needs the word false. If I don't put in false, it'll assume that I want a cumulative distribution that I do not want. And for some reason, I've stuffed this up. Normdist. I think that's right. This is me checking my work. This is the back end that sometimes you guys see and sometimes you guys don't. Normdist, value, mean, standard deviation, false. Normdist. Equals Normdist. Oh, cool. I did not put in the standard deviation because I suck. No, I don't. Sorry. Because I am tired. There we go. Okay, but it's got to be in the right order. So it wants the standard deviation first. Fix that value by pressing F4. No, it was the mean first. Fix that value by pressing F4. Then it was the standard deviation. So comma, standard deviation, comma, delete, false. Cool. Yay! Copy that down. D36. Because that looks about right. I have made a mistake, and I don't know what my mistake is. Cool, I'll just start from scratch. Got no idea what happened then. Sometimes it's just best to go back. Okay, equals norm. Open bracket. X value. Comma. Average. F4. Comma. Standard deviation. F4. Comma. False. Enter. Change the N to an M. Copy down. Yay! I hope you skipped that part. I really do. Okay, equals. These numbers are far too small to be graphed against these ones. Okay, because they're out of 1 and they're out of 360. So we need to times that by 365, because there's 365 days in a year. Okay, now I'm going to make my graph. This is the data. This is the normal. Control, because I only want these two columns. I don't want that middle column. That's a working out column. It should not be graphed. Then I go to insert, chart. Okay, and as you can see, it's already close. And this one's actually looking a little bit more normal than the first one I showed you, which isn't bad. Okay, one thing I would do, combo chart, that's correct, is go to customize, chart style, smooth, and then I think that's done. Okay, that's your data against a normal distribution. Okay, and as I said, you can use that to answer questions from the textbook. You can make up your own question. Just remember, you can make this project as elaborate as you want or as narrow as you want. The choice is yours. Okay, hopefully that was helpful. Go through, do the steps, and I hope to see you soon. Bye, guys.